do the last handful of questions that are on that assignment. So I know I've got two here. It says write an equation of a circle with diameter diameter AB. I think this one, 38, is a little bit more difficult because it doesn't incorporate the ordered pair 0, 0. So I want to do that. I want to do 38 because it's probably going to be more realistic to what you'll see on your homework. I think with these, it might make sense to draw a picture. Okay. Now I'm telling you the ordered pair of the endpoints of your diameter, right? So now my picture doesn't have to be great. I'm just going to use it to help me realize what I'm doing here. But we've got one diameter endpoint right there at 3, 0. And the other one here is at 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So 7, 6 is right there. So those are the endpoints of our diameter, correct? Now, here's the reason I draw that picture. Obviously, here would be, it's going to be stink at drawing circles. But let's say that's our circle. What thing, what item or object do you need to construct the equation of a circle? There's two things, actually. Can you tell me both of them? You need the center, you need the radius. Why do I draw the diameter? Okay, the diameter is 2 times the radius. So I need the diameter's length, and I can cut that in half to find my radius, right? So that's important. Why is the diameter important to the other aspect of the equation, which is the center? Okay, so the center is located at the what? You said cut in half. But that is the what do we call that of that segment? Midpoint. Okay, that's going to be the midpoint. You guys remember the formula from chapter 1 to find the midpoint of a segment? Okay, you add your x's, divide by 2. You add your y's, divide by 2. Okay, so if I want the center of the circle, which is the midpoint of the diameter, I'm going to take that x and that y, that x and that x, 7 to 3, add them together and divide by 2. So what's that going to give me? Give me 5. And we'll take that y, add them together, divide by 2. What's that give me? 3. Okay. Now, if I drew my picture somewhat to scale, 1, 2, 3, 4, 5, and then up 1, 2, 3, that looks like roughly the center, right? Okay. But I know that's the center right now of our circle. Now I need to find the radius. And there's 2 ways of doing this now. If I found the center first, okay? When I find the radius, that is the distance from the center to one of these points, right? Okay, distance formula is this. Correct? Okay, that's the only way we can do this. All right. You either find the distance from the midpoint to an endpoint, or you can go endpoint to endpoint and find that distance and divide that by 2. Does that make sense? It's totally up to you the route you want to go. But know what points you're using so that you know, if I'm using those 2 points, then that is directly the radius. And I don't have to do anything after I find that distance. But if I use that point there and that point there, I'd be finding the length of that purple segment, which is the diameter, and that does not belong in the equation for a circle, so I'd have to cut it in half, right? So I'm going to do, just because I don't like to cut it in half, I'm going to find the distance of that radius. Okay. Now, does it matter which endpoint I go to? Can I go to, from 5, 3, can I go to 7, 6? Or can I go to 3, 0? Doesn't matter, right? Which one would you choose? Why would you choose 3, 0? Because of the 0. Because we're going to do subtraction here in the formula, and if I've got zeros, 0 is an easy number to subtract from. Okay? So I'm going to say that my midpoint, we go 5 minus 3. Square that. Add to it then 3 minus that 0. Subtract my y's. So 5 minus 3 is 2, squared is 4. 3 minus 0 squared is 9. So it gives me radical 13. That's my radius. Okay? Just quickly, just so that you guys can see that it doesn't really matter, if I would have gone to the other point, if I would have gone from 5, 3 to 7, 6, I go 7 minus 5, subtract the x's, and then 6 minus 3, subtract the y's. Well, 7 minus 5, 2. 2 squared is 4. 6 minus 3 is 3. 3 squared is 9. Still radical 13, right? If you would have gone from that point to that point up there, if I subtract those x's, 7 minus 3 is 4. I'll square that and get 16. 6 minus 0 is 6. I will subtract those, square it, get 36. And that ends up giving me, what, 52? Now here's the issue. When I look at that radical 52, it doesn't look like 13. Okay? Like this radical 13, right? And it's not. It's twice as big. So what we need here is to realize that 52 is the same thing as radical 4 times 13. What's the square root of 4? 2. So I get 2 radical 13. But that 2 radical 13 is still not radical 13 because this is a diameter, right? What do I need to do with that to get the radius? Divide by 2. Still gives me radical 13, right? My hope is that you realize, though, that there's some radical work there that doesn't exist down here when I use the radius, the center, and an endpoint. Does that make sense? Any route's fine, though. R is radical 13. So when we plug this into our formula to find the area of, not to find the area, to find the equation of a circle, it's x minus h squared plus y minus k squared is equal to r squared, right? H and k are your center. That's going to be x minus 5, y minus 3, and r squared, r was radical 13. What do you get when you square that? You get 13, right? Okay. Now, a lot of work there. So my suggestion to you is take the time to take that equation, go into Desmos, type it in, see what they give you. Okay, so we had x minus 5 squared plus y minus 3 squared. It was 3, right? Yeah. Equals 13. So I get that. I'll plot the point 5, 3 on there. So you can plot points just by typing in the ordered pair. We also had the point 3, 0, which was the one endpoint, right? We had a point 7, 6 was the other endpoint. Do those 3 points, does the purple one and the green one land on the circle? And that should be enough to justify that we've done this correctly. If I would type in, let's say my circle for whatever, let's do this, because this is the number one wrong answer that people do, is that they'll put square root of 13 in here on the right-hand side. Oops. So they'll do that. They'll mess up the R. But if I plot everything, you see how those points that we started with that said they should be on the circle or not? Tells you that something's amiss. Okay? So we went to 13. Those are on. They look collinear. All right? And there is a way to put in lines here, but I'm not going to take the time to do that. But you could line those up with a straight edge and say that they are collinear, and that's the information we started the problem with. So we know we got the right equation for our circle. Does that kind of make sense? What would be the area of that circle? What's the area formula for a circle? Careful. Area is pi r squared, right? What's r squared? Pull straight from this. What's r squared? 13. So area is 13 pi. Circumference, 2 pi r. Pi, okay, so careful. That number right there is r squared. R is radical 13, right? So we have 2 pi times radical 13. That's the circumference. So we can get those two. Those are the things we've been talking about previously in Chapter 10 about the area of circles. They can still ask questions like that, and they still do ask questions like that. Okay? They might tell you that, and I think the next question I have here does this. They tell you the center of a circle, but they do not tell you like endpoints of a diameter or anything like that, like we just did, to find the radius. So what they do is say, okay, if you want to write an equation for the circle with a center at 4, 7, that part we can do pretty easily, right? Okay, so a circle is always going to be x minus h squared plus y minus k squared equals r squared. Right now, that's h and k respectively. So just plug that in. X minus 4 squared plus y minus 7 squared. But if I just have it, there's actually an infinite number of circles that have that center. Does that make sense? Those circles would all look like this. Let's go. X minus 4, 7, right? And let's say that that is A. Let's create a slider for A. Though an A can only be from, let's go 0 to, let's just go to 100 right now. If I were to let A be any number, you see all those different circles that have the same center of 4, 7, right? Okay. And if all those circles have a different radius, then all those circles obviously have a different area, correct? We want to find the one that has an area of 36 pi. Okay, so if area is equal to 36 pi, okay, so the area formula is pi r squared should equal 36 pi, right? That makes sense? What happens with these pi's? They cancel out. So r squared ends up being what? Careful. R squared is because I divided both sides by pi, right? And those canceled. So I'm left with just r squared on the left and just left with 36 on the right, correct? So r squared is 36. Now, if you want to go further and find r, you can. But when I plug it into my formula, what is this on the right-hand side? It's r squared that they want, right? So I'm going to put 36 there. So then that would be the one circle that we're looking for. It has a center of 4, 7, and now an area of 36 pi. Does that kind of make sense on how to do that? Okay. So they're always going to give you a technique or a pathway that's going to allow you to find your center and it'll allow you to find your radius. Okay. They just might hide some of that information to you. Okay. Let's say that this is a common one that people struggle with. Let's go. I'll just write one here. Let's say we have a will be the last one we do. A circle with center at 4, -8. Okay. And is tangent to the line 4, 8, y equals 3. Okay, so that what one aspect of that problem that says tangent to the line y equals 3. The y equals 3 a lot of times is they might say y equals 0, which would be the x-axis. So they might say just the x-axis. They might say instead of y equals 3, they might say x equals 3. Might say x equals 12, whatever. Okay, so this line can change. Okay, they could. So all the problems that we're going to see in this class, this line is going to be either vertical or horizontal. It just makes things a little bit easier. They could, though, and it incorporates then a lot more thought and algebra, but they could make any line here that they want. So like y equals 2x plus 3 or something like that. Okay. I like to draw a little bit of a picture here when we do these. I think right off the bat, we should know that there generates x minus 4 squared plus y minus -8, so plus 8 squared. Does everybody agree with that? Generally, it's going to be very easy for you to find the center, or they explicitly give it to you. So here we're looking for a radius. Okay? But if I look at the point 4, -8, so let's go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 4, -8 should be right there, right? Okay. So if we, again, just go to this here, okay, that's the center for -8. We've got that center, right? But as before, there's a lot of different circles. Would you guys agree? So if we said the line y equals 3, right? Y equals 3. We got to be tangent to that line. Is this circle tangent to that line? No. Oh, didn't go far enough. Okay, so let's go. I think they go to 120. Is that circle maybe tangent to that line? Okay. So what we have to do then is figure out, okay, well, if that's the case, what is that distance right there? What is that length of R? Is that okay with everybody? Okay. So what I like to do is, because I know the line y equals 3, so I'm going to go 1, 2, 3. I'll draw that picture in, that component to my picture. And now what's nice is because, and this is why we keep these as horizontal or vertical tangent lines right now, is because if I want to be tangent to this line, that radius right here is now a vertical distance, right? Okay. This y value is +3. The y value down here is -8. Okay. What is that distance between -8 and 3? 11. So my radius is 11 here. Does that make sense? So what is the radius squared? 121. Okay. So when we look at Desmos here, Desmos was showing A to be 120, right? Okay, but let me zoom in on there. Whoa, wrong button. Let's zoom in on there, and this is the idea of calculus. Even though when we look back at it like this, it looks like they touch, right? If we zoom in far enough, they do not touch. Okay, so if I make that number 121, now zoom in on that point right there, that will be the only point in which these two curves, the line and the circle touch. So that would be tangent. Does that make sense? So they hide, there's so many different ways, and that's just a few that we're going to use in this class. There's so many different ways they can hide the center to you and hide the radius to you. Is everybody okay with those? Do you have any questions about this? X minus h squared plus y minus k squared equals r squared every single time. Okay. I wanted to today to get into like starting with an expanded version of your circle and factoring it to get down to this format, but I think you guys have been pretty good this week with going through all this stuff, and it's going to continue to be a little bit hectic until we get through the end of course exam. So I'm going to give you the rest of this period just to work on an assignment, get that done. So we start fresh Monday. Monday, my goal is to get into transformations a little bit, which are not going to, transformations are not something that's going to blow your mind, something you've done before. Show you some tricks and techniques that we can use that might help us on the test with those, and in the following week, probability. So 12.5 is open.